this is a converging mirror.
That's right. Concave mirrors are converging. We just have that memorized.
So in the table, we say it's upright, virtual, and magnified.
How do you know that you're in this region and not, say, this region? How do you know which of these three regions to use?
Because if it's in between focal length and then...
Yeah, you got it. So you can see just from looking at the picture that I drew it within the focal point. So we know we're here. Of course, if it was diverging, it wouldn't matter where it was. But since it's converging, we have to know which region we're in. All right, so you were right when you said it would be upright, virtual, and magnified. So it's always good to start by using the table as our prediction. Okay. So the first ray comes in parallel. And then is it going to get bent up or down?
Down.
Because this is converging. The only way to converge is if it's going down like this. Good.
So it goes through the
Good.
And the second one goes to the center of there.
Right.
And then it goes the same level.
Yeah. The second ray we draw straight to the middle of the mirror, and then it bounces off at the same angle that it came in. Uh-oh. Okay, good.
To trace that.
Mm-hmm.
So
Okay, good. Now notice that we did not have to use any tracebacks to draw the outgoing light rays here. Even though we knew ahead of time that we're going to have to use some tracebacks because it's virtual. But you don't really know, you still have to figure out which tracebacks we need. We didn't need any tracebacks just to draw the outgoing light. But if you look at the picture here, these are not going to intersect. Now the problem here is, actually, it might be hard to tell whether they're going to intercept if you don't have a straight edge. So it helps to know ahead of time. A virtual image is formed by tracebacks. So we knew ahead of time that we have to form the traceback here. And when we do the traceback, we get the convergence, say over here. I actually had to kind of twist this angle here to get this to converge, because otherwise it would be way off the page. But this angle is supposed to be the same size as this angle. All right, so this would be our image. Does that confirm our prediction?
yes.
Upright, virtual. How do we know it's virtual?
Because the outgoing ray is on the opposite side of where the image is.
Yeah, the image is on the right, but the outgoing light rays are on the left. To a person that was looking, it would seem like the light is coming from here, even though there's nothing but wall here. Okay, good. Okay, I think that one didn't give us too much trouble. All right, but one lesson to think about here is if you think about the last 2 or 3 sessions that we've probably done about 8 or 9 or 10 of these ray tracings, and almost all of them we've had some hiccups through there, and that's perfectly normal. Most students never get ray tracing, and there's one simple reason: they don't do enough practice. Because so there's basically 1, 2, 3, 4 different cases, but there's also lens and mirrors. So there's really 8 different pictures. There's 8 different pictures, and you just have to sit down and take a couple hours maybe, and just keep writing those 8 different cases over and over. There's no way we can do enough practice in the tutoring, basically, to do that, because there's all these little hiccups that come up. So you just need to find the page in your textbook that gives you the right answers, and keep covering it up and drawing the picture. And eventually, you'll get past the hiccups and be able to draw them well. We've done enough work, I think, to see what the basic principles are. Okay, and it always helps to have you use the table ahead of time so that you know that you're going to use tracebacks for virtual images over here, because sometimes otherwise it's hard to tell whether the lines are going to converge or not from your picture.